The first roller coaster dates back to the 18th century. It was an ice slide made in Russia. This attraction was called a Katynaya Gorka or sliding hill in Russian. The slides were built to a height of 70 feet, had a 50-degree drop, and were reinforced by wooden supports. Sometimes wheeled carts were used instead of sleds. In 1846 the first looping non-circuit coaster called the Centrifugal Railway, was made in Frascati Garden, Paris. In 1959, Disneyland introduced a new design in roller coasters called the Matterhorn bobsleds. This was the first roller coaster to use a steel track. At the top of the first 1.14-meter hill, the 0.054 kilogram marble has a potential energy of 0.604 joules. At the bottom where it is going the fastest, the velocity is 4.739 meters per second, and has a kinetic energy of 0.604. This is all assuming no energy is lost to friction. Going through the cloudhoid loop, the marble should drop to 4.249 meters per second, with a centripetal acceleration of 90.252 meters per second/s, and at the bottom should return to its greatest velocity with a centripetal acceleration of 111.817 meters per second/s. At the peak of the camelback hump at 0.07 meters the velocity should be 4.583 meters per second before returning to its highest kinetic energy. However, since there is actually a noticeable amount of friction, there is a lot more velocity lost over the course of the track, and it no longer has the speed required to make it up the first hill again to where it started. In layman's terms, the ball starts high, as it travels downwards it both gains a considerable amount of speed and loses a bit less from the marble rubbing against the track. As it continues through the track, it has enough speed to get it through the loop and bump, but it is still rubbing and still losing speed, and because of this the marble does not have enough energy to return to the beginning of the track.